All right, everyone. Come on over here to the stage. Come on over. Are we having fun so far? Oh, come on, you can do better than that. Are we having fun? Okay, all right, that was a little better. Well, everyone, I would love to welcome you back on site for our official start now here of Kids Week at the Intrepid Sea, Air, and Space Museum. Round of applause for that. All right, and also everyone, welcome to those of you who are tuning in at home too. We are live streaming right now, so wonderful to see you all here as well. So my name is Alicia, and I am so excited to be here with you all today. We've got so many exciting things planned throughout Kids Week as well, not just today. We've got activities, we've got demonstrations, we've got our friends from NASA here set up with some cool exhibits and things to do as well, and also an astronaut coming to talk to us later today as well. So all of this and so much more. But to start us off here, everyone, you may not know this, or maybe you do, but our museum is actually home to 28 of the world's fastest airplanes. We've also got the Cold War era submarine Growler right outside to check out. And of course, up in our Space Shuttle Pavilion, we've got our amazing Space Shuttle Orbiter Enterprise. Have you all seen that yet? Did you all notice anything else up there, actually? We have a very cool thing up there. We've got the Mars rover and the Mars helicopter up there too, right under the space shuttle to check out. So make sure you go see that later on today. But you are in for a very special treat right now, everyone. I would like to introduce right behind me my good friend Jonathan Millard.
Hello,
Everyone give a round of applause for Jonathan Millard. He is with our
thank
education team, and he is now going to do a really cool demonstration on how things fly. So take it away, Jonathan.
Awesome. Thank you so much, Alicia. Can everyone hear me okay? Yes, great. Welcome, everyone. Like Alicia mentioned, we have a lot of cool aircraft. Raise your hand if you saw a cool aircraft today, a plane or a helicopter. Oh, wow, I see a lot of hands raised. That is great. So today we're going to be talking about how things fly. So does anyone have an idea what helps things fly? Does anyone want to share with me and just say it really, really loud? My friend here. Oh, okay, so maybe if we're thinking about gravity, maybe when we're flying, we're fighting gravity. So maybe somewhere with not as much gravity might help us fly. Interesting. Yes, my friend here, say it really loud. Say what? An engine? Yeah, an engine. Yes. So a lot of these aircraft that we're seeing today have powerful engines to help them fly really fast in the air. Any other ideas what helps things fly? My friend here, say it really loud. Oh, propellers. I love how my friend mentioned propellers, those things that spin and help things fly in the air. We're going to talk a little bit about propellers today. Any other idea? Yes. Okay, so wings. And oh, that was what my friend, you were going to say that too? Awesome. Yeah, give me a thumbs up if you're going to thinking about wings too. Yeah, so something that these things all have in common is they have something to do with air. And we're going to investigate air today and how things fly. So even here someone mentioned birds can fly. And yes, birds have mastered this art of manipulating air and helping them move around in the sky. So let's talk about some things that can fly. I have a very small drone over here. And what we're going to do, we're just going to see what happens when I turn this drone on, okay? This is not, this is my friend Zip. My friend Zip is a good drone, but sometimes he has trouble flying. So let's see how he goes, okay? So I'm going to have Zip fly. Oops. There we go. All right, and we saw Zip flew up into the air. Zip has 4 rotors or 4 propellers that help Zip fly in the air. And we're going to investigate what is going on when Zip flies. It's because over here, I have a bell jar. And what's interesting about this bell jar is that it's attached to a vacuum. So what I can do with this vacuum is I can take all the air outside of this bell jar here. And now that there is no air inside this bell jar, how do we think Zip is going to fly? Do we think Zip is going to fly really well? Give me a thumbs up if you think Zip's going to really fly well. Give me a thumbs down without air. Do you think Zip's not going to fly so well? Yeah, we're going to take all the air outside of this bell jar. So let's see. I'm going to try turning Zip on. And Zip is on right now, but Zip is having trouble flying. Why do we think that Zip is having trouble flying, friends? Oh, yes. It doesn't have air in here. And that's really interesting because that makes me think that things need air to fly. And what's very interesting about that is if we go upstairs into the Space Shuttle Pavilion, you're going to find a very interesting model, a model of the Ingenuity helicopter, which is the first controlled powered flight on another planet. That is really cool because the planet that the Ingenuity is flying on is Mars, and Mars has an atmosphere, but it's not as great of an atmosphere as the atmosphere on Earth. Earth has a wonderful atmosphere, a little bubble around it that keeps all our air inside, and because all that air is inside, we can have these things fly on Earth. But on Mars, the atmosphere is 99 times thinner than Earth's. So to have something fly there, we have to make that aircraft very light, and the propellers have to spin really, really, really fast to help that Mars helicopter fly in space. Okay, so I'm going to turn off Zip now. Okay, and I'm going to turn off my bell jar here. Great. And we're going to investigate air a little bit more today. Okay, so what I have to investigate air is this bag over here. So what I'm going to try to do is I want to fill this bag with air. Do you think I could easily fill this bag with air? Give me a thumbs up if you think yes. Give me a thumbs down if you think no. I'm seeing some thumbs up, seeing some thumbs down. All right. Can you give me a countdown? We're going to count down from 5, 4, 3, 2, 1, and see if I can fill this bag up, okay? So we're going to start. 5, 4. Do you think that's a way to fill this bag with air? No, it didn't seem that great. Oh, I have an idea. I have a bicycle pump. This fills tires really well. Maybe we'll fill this, okay? Do you think I can fill it with this? Give me a thumbs up if you say yes, thumbs down if you say no. Okay, interesting. All right, I want another countdown. Let's see if I can do it. So give me the count of 5. So 5, 4, 3, 2, 1. So 5. Oh, that made me tired. Okay, I don't think I can do it that way either. But I actually remember there was a scientist by the name of Daniel Bernoulli, and he had a really cool idea about air pressure, okay? And his idea was air does something really interesting when you have an airflow. So I'm going to try to fill this one last time, and I want another countdown. Okay, so 5, 4, 3, 2, 1. So 5. Oh, I already filled it. Wow, that was really cool. So that's really cool that air can work that way. So what we're seeing here is something really special. Okay, I want everyone to imagine your favorite food. Okay, I want you to imagine your favorite food. Imagine that there are 2 lines to your favorite food. Okay, 2 lines to your favorite food. One line is moving really fast. A lot of people are really going up to that counter and getting that food really fast. The other line is moving really slow. Do you want to be on the slow-moving line or the fast-moving line? Yeah, I would want to be on the fast-moving line too. And that's what air wants to do. So let's see this in action. So I have a fan over here. And what I'm going to start doing is make some fast-moving air. Making some fast-moving air. And what's happening is because there's fast-moving air here, all the slow-moving air around it wants to go where the fast-moving air is. So it's pushing in on these beach balls here to actually hold them in place and to keep them flying. So I can demonstrate this with something else too. Let me reduce these and see if I can grab these. There we go. I'm going to do this with an even bigger beach ball. Okay. And what's so cool about this is because we have this zone of low pressure where this air is moving really, really fast, we have high pressure pushing on this, keeping it in place. And I can even move it at an angle and still see this happening. All right. Okay. So if you guys are taking like pictures right now, I'm going to pretend like I'm like have superpowers and you can like make it look really cool. All right. Don't tell anyone else what's happening. This is a secret between you and I. All right. Okay. Really cool. Thank you. Okay. All right. So there is nothing really holding this in place other than the air? There are no strings attached. Okay. I have this hula hoop around it. Okay. And we're seeing what's holding this beach ball in place is the air. Okay. So one way to think of this is through Bernoulli's principle, that idea that you have high pressure and low pressure. So you have the low pressure moving really fast and high pressure pushing on that spot. So to get to where low pressure is. This is also how planes are flying too, because as a wing cuts through the air, because of the cool shape of a wing, gets pushed over the top. So all that fast-moving air is on the top of this wing. And where do you think the high pressure is? If the low pressure is on the top, moving really fast, where do you think can you point to where you think the high pressure is? Point to where you think the high pressure might be. If it's low pressure on top, it's high pressure on the bottom, and the high pressure is pushing up on this wing to help this plane go up in the air. Another way to think of this, and with our beach ball too, is with some ideas from a friend we might be familiar with, Isaac Newton. And he had an idea about how things moved. And he had laws of motion. And his very third law of motion was that for every action, there's an equal and opposite reaction. There we go. For every action, there's equal and opposite reaction. A way for you to think about this with the wing is if as the air is being moved around the top of the wing, it's getting pushed downwards here. So what do you think the opposite reaction would be if you're pushing the back downwards? Yeah, so the front is actually going to go up a little bit. And in this case, with our beach ball, what's happening here, as the air moves over this beach ball, it's getting pushed down. And what's the opposite reaction? Going up, helping that beach ball go up. You can also think about propellers this way too, because we have a few helicopters in the museum collection. So take a look at these helicopters because their propellers are on the top. So I have a propeller here. And what I'm going to do, I'm going to spin it. And as I spin it, that air is going to get pushed down. So what direction do we think that this little aero prop's going to go? Can you point what direction we think it's going to go? If I'm pushing down, there's an opposite reaction. It's going to go up. So let's see it happen. Wow, right? So you're actually able to see this go up because we're pushing that air down. I'm going to leave that there for one moment. I'm going to bring this up as well. Okay. So what we're seeing with how things fly, this can also impact things that don't necessarily look like a wing. So all different types of shapes can be affected by air and still fly in a way, okay? So here I have something called Magnus Cups, all right? And what happens when I release this rubber band, we'll see that it actually lifts up a little bit. I'm going to do that one more time so you can see it. Going to add a little bit of tension as air moves around this object. All right, it flies. All right, great. Okay, you can leave that there. No worries about that. So this actually impacts a ball as it's flying through the air. Thank you so much, friend. This actually impacts a ball as it's flying through the air. A curve ball you'll see in baseball or softball, that's impacted by the airflow moving around that ball. So I want to demonstrate one last thing since we've been talking about how things fly. I showed a drone earlier. I have another drone here. Let's see how this one flies. So we're talking so much about how things fly. Let's see what happens with this drone over here. Okay. All right, so we can actually see a drone flying in the air with using its rotors to be able to move around and do a lot of cool things. Oh. All right, and we actually saw it doing a fun little nosedive there. But you were able to manipulate air in so many different ways with flight, and I hope as you explore the museum, see the different aircraft, think about what helps these aircraft fly, and take a look at the Ingenuity helicopter up in the Space Shuttle Pavilion as well. So thank you so much. That's the demonstration. If you have any questions, I'm going to mask up, and if you can come up and ask me. Thank you so much.
All right, put your hands together for Jonathan Millard from our education team. Wasn't that amazing? Did you guys know all of that about air? How cool. I especially really appreciate the example with the food too, because aren't we kind of hungry, right? It's around lunchtime. All right, so everyone, just so you know, the education department has programs both at the museum and virtually, and it's geared for all ages. So pre-K through 12, after school, teens, seniors, you name it, we got it. So if you're interested, just check out our website, intrepidmuseum.org/education. Now, as I mentioned before, you might have noticed that our first few days here are all about NASA. So we do have lots of cool friends here today with lots of activities and exhibits around the floor. And we've also got an education maker zone set up right over here where earlier today you could make your own mission patch. They're going to be bringing that back later too. And soon you're also going to get the chance to make your own Mars rover. And did I mention we have a Mars rover on site here, guys? Have you seen it yet? Anyone seen it yet? Upstairs in our Space Shuttle Pavilion, we've got the Mars rover and Mars helicopter models. Full scale, they're amazing. Please go check them out upstairs. Don't miss it before you leave. And so everyone, also just don't go anywhere because at 1 o'clock, we are going to be bringing on stage here with us another very special friend from NASA, a NASA astronaut, Victor J. Glover Jr., who's going to talk to us a little bit all about what life is like in space. So everyone will be right back here at 1 o'clock. Don't go anywhere. And that goes for you all tuning in at home too. Don't go anywhere. We'll be right back here at 1 o'clock. Have a great Kids Week, everyone.